Pydantic AI's core mechanism for directing a language model towards structured, typed output begins with the agent class and its output type parameter, which binds a Pydantic base model to the lifecycle of a single run, so the model's response is validated against a schema before it ever reaches your code. The result of that run is wrapped in agent run result, giving access not only to the typed output, but also to telemetry like token usage. Initializing an agent with a model identifier and a concrete output schema, then invoking run sync with a plain text prompt, is the minimal path from question to validated data, and the following code demonstrates exactly that pattern. From Pydantic import base model. From Pydantic AI import agent. Class CityLocation base model. City, SDR. Country, SDR. Agent equals agent Google GLA. Gemini 3 flash preview. Output type equals CityLocation. Result equals agent. Run sync where the Olympics held in 2012. Print result, output. City equals London, country equals United Kingdom. Print result, usage. Run usage input tokens equals 57. Output tokens equals 8. Requests equals 1. This is a minimal agent setup using Pydantic AI's agent class, passing a model identifier and an output type of a CityLocation Pydantic model. The agent forces the model to return structured data matching that schema, and run sync blocks until the response is complete, returning a run result that wraps the output. Structured output via output type gives you type-safe results you can work with directly, but it adds a round trip through tool calling that plain text wouldn't need. The usage method on the result is handy for tracking token costs and request counts in production, though you pay for the extra schema validation overhead on every run. Let's break it down line by line. From Pydantic import base model. Imports base model from Pydantic for defining data models with validation. From Pydantic AI import agent. Imports agent from the Pydantic AI package. Class CityLocation base model. Defines a class named CityLocation that inherits from base model, establishing a structured data model for city location information. Agent equals agent Google GLA. Gemini 3 flash preview. Output type equals CityLocation. Creates an agent bound to the Gemini 3 flash preview model that expects responses conforming to the CityLocation type. Result equals agent. Run sync where the Olympics held in 2012. Invokes the agent synchronously with the question, where were the Olympics held in 2012? And stores the completed response in result. Print result, output. Prints the output field from the result object to stdout. City equals London, country equals United Kingdom. Print result, usage. Calls usage on the result object and prints the returned usage data to stdout. The whole thing is one loop. Base model defines the shape, agent binds that shape to a model run via output type, run sync drives the round trip, and the result comes back wrapped in typed output plus usage metadata. Structured output costs you a tool calling round trip you wouldn't pay for plain text, but you get type-safe data you can work with directly instead of parsing strings. That trade-off is the point of the pattern.
CityLocation defines blank fields, yet run sync fills them with London, United Kingdom.